So the example you can see, is from the video before, where we kind of spoke about spotting how the chain rule could affect our answer, how we could get our answer. So I'm actually going to show you using this previous example, and then I'm going to do two formal examples to kind of show you what to do. So with this one, obviously we've got y equals 3x take 1 to the power of 5. I'm going to let u equal my brackets. So I've got u is equal to 3x take away 1. Okay, so now I've got y is equal to u to the power of 5, which is a lot easier to differentiate. Okay, that's just normal differentiation here. But we obviously can't just do it kind of straight away. So we know that if y is a function of u, so if y is a function of u, okay, which y is a function of u here, okay, but where u is a function of x, okay, so we've got if y is a function kind of with u in it, where u is a function with x in it, then we have that the differential of our original function is equal to, so this, the differential of this is equal to the differential of y with respect to u, so the differential of this times the differential of this with respect to x. So we differentiate this with respect to u, and then we differentiate this with respect to x, and we multiply them together. Okay, so that's what we're going to do. So we've got dy dx equals, well, what's the differential of y with respect to u? So differentiate this, so you get 5u to the power of 4 times my differential of this with respect to x. So differentiate this, we would get 3 on its own. Okay, so that gives us 15 u to the power of 4. Okay, but u we need to change back to what it was before, so we end up getting 15 lots of 3x take 1 to the power of 4, which is exactly what we got in our last video, but now we kind of have to set it out in a more formal way. So we're going to talk through these examples here. So this is the first example that we're going to do. So example 1. Okay, so you can write it down if you need to. So we've got dy dx is equal to dy du times du dx. Okay, so that is what we use for our chain rule. So this, currently, remember we set our brackets for u. So u is equal to 4x cubed take 9. So that leaves us with y is equal to u to the power of 8. Okay, so our differential dy dx is equal to, I differentiate y with respect to u, so I get 8u to the power of 7 times, then I differentiate this with respect to x, so I would get 12x squared it's gone a bit blurry, sorry. Okay, so then I would end up getting 8 times 12 is 96x squared u to the 7. I've just simplified that. My 8 times my 12 is 96, my x squared is here, and u to the 7 is there. And our final step is just replacing u with what it was before. So we end up getting 96x squared, brackets, replace my u, so 4x cubed take 9, all to the power of 7. Okay, so that is my differential. And the last example that we're going to kind of go through is this one. this is a squared. Okay, so we've obviously got to do something first. I'm going to write down what we use just in case, but we should start to become kind of a bit happier with this. I'm not going to prove it on the video, we will do it when you come back to school. So this I need to rearrange into the correct form first of all. So I've got 2 lots of 4x squared plus 5 to the power of negative 6. Okay, so that's, I've just rearranged, well, I've just written this in a different way. Changed my power to a negative so that it's all kind of in one place. So my u is equal to my brackets, so 4x squared plus 5. My y is now equal to 2 lots of u to the power of negative 6, so 2u to the power of negative 6. So my differential, dy dx, is equal to, so because I've written it up here, I haven't been writing it here, so it might be useful for you to say, well, dy du times du dx, and then kind of write out. So you're writing this first so that the examiner then knows that you know what you're on about. So differentiate my y with respect to u, I get negative 12u to the power of negative 7 times my differential of this with respect to x, so I would get 8x. Okay, then I can kind of sort that out a little bit, so I get negative 96x u to the negative 7. Well, now I need to replace my u with what it was before, so I get negative 96x brackets 4x squared plus 5, so that's my u, all to the power of negative 7. Okay, so try to add this step in so that the examiner knows you know what you're on about.